Hello there, welcome to this video. This is another one of those Q Python programming tutorials. So in this video, I want to talk about server priorities. That is, when you have multiple servers at a node, it has to make a decision about which server is actually going to provide the service. That kind of, we might say, symmetry has to be broken somehow, and priorities are one of the ways to do that. So based on the documentation, I've set up some computational experiments for us to go through. We're setting a seed number and we're going to simulate for 1,000 units of time, but it's not going to particularly matter for this example for what we want to show. The first example is to have utilization with no explicit priority functions given. However, tacitly, one of the things that you should understand is that actually what Q will do is Q will prioritize them in order of server ID number, which personally, I think is weird because it's arbitrary. You might as well have it in random order. Maybe at some point there will be a pull request around that, but that's my feeling, is that generally you should just randomly sample among the ones that are available, but that's not what happens. You're going to see in the results that it's going to be based on the priority number. So we'll set up a network here, and this is just an MM3Q. So we got exponential with a rate of 1 for the arrivals and exponential of rate of 2 for the service distribution. And we have 3 servers, and we're going to do some simulations here and extract results. So we'll set our seed and we will run a simulation, and then we will simulate until that maximum time of 1,000. And then we're just going to, after the simulation is done, for each server, grab the utilization at that first node. There's only one node in the system, otherwise you could unpack that further for each node. There's a bunch of servers, but we're good here, only one. So we'll grab that information and we're going to plot it later. Then for the second system, prioritize based on busy period. And here we're going to do this using a function. This is just a custom function that we could call almost anything we like. In this case, we're calling it server busy time, like the documentation does. And it needs to take in 2 arguments. It needs to take in a server, and it needs to take in an individual. So there is a server type in Q, and maybe we'll talk about that more some other time. And also the Q's individual type that we've seen before. And based on the priority, is just to say we return the busy time as the priority level, and it gets that, it calculates that for every server and basically takes the highest priority one. So, or lowest priority, well, smallest busy time as the highest priority. So we've got utilization busy period priority. We're just setting up our similar computation. This is also basically an MM3, except, so it's all the same, except we've set the server priority functions here to be this server busy time. And again, we have the same setup. We're calculating exactly the same results. So let's jump into basically running this. We're going to run and return the utilizations for the no priorities and for the busy period priorities, where the smaller the busy period, the higher priority that you should assign work to that worker. And we're just going to print those. Nothing else that's really of note here. So let's run it. And here we go. So that first line are, remember, doing whatever Q thinks is the default of just assigning whatever is the lowest ID number server that it happens to also be available. And so that's why you get this progressing, or sorry, decreasing from left to right here, that the 0th server was giving service at a utilization of 0.31. The next one down was about 1.14, and the last one after that is about 0.04 utilization. And the reason why it doesn't add up to 100% is because they're not busy 100% of the time. The overall server distribution rates are pretty high, and there's 3 servers, and so it easily outmatches the arrival time. Okay, so the arrival time process. So it's not these are not services that are busy all of the time. And this particular aspect of choosing which server for this particular simulation setup doesn't affect how fast only which server gets selected among the ones that are available. So if we were to look into the amounts of completion rate overall, they shouldn't be different. However, how it is split up is different in terms of utilization here. So our prioritization of giving more work to the least busy worker ends up with a more equal distribution of utilization, all of them looking like they're about 0.167 or 8-ish. That's one thing to be aware of with Q, is that it does have this unusual server and server priority system by default, and that if you're looking to have something that's maybe a bit more natural to a problem that you're working on, you may want to set it to yourself to be something that makes sense in terms of the business logic, or even just setting it to be uniformly random so that it's never really a useful factor, that it won't cause any statistical dependence in the simulation results. So with that, I hope you found that was interesting and useful little tidbit about how Q works, and now you know how to set your own server priorities. Maybe I'll just say one more thing, which is keep in mind you can write this function in a wide variety of ways. You didn't have to base it on busy time. You could return something else. And you could, for example, as we've talked about in earlier videos, through an individual, you can actually access pretty much the whole state of the system. And so you could make this based on all kinds of things. And actually, I think you should even be able to get access to the simulation time here. So you actually have indirect access to time and state of the entire system, as well as the particular server. Okay, now I think we're done chatting about this. I will wish you a good day and enjoy writing Q simulations. All right, take care.